Welcome to The Explainer. Today, we're diving deep into something that happens millions of times a day in businesses all over the world, an Active Directory update. We're going to pull back the curtain and see how this system keeps its massive, globe-spanning database in perfect sync.
So, let's start with a really simple question that gets right to the heart of it. How does a single password change, made on one server, almost instantly get recognized by thousands of other servers, maybe even on the other side of the planet? The system that pulls this off is, honestly, a masterclass in distributed computing.
Okay, so to unpack that, here's what we're going to cover. First, we'll look at the huge sync challenge AD was built to solve. Then, we'll see how it cleverly breaks down its data. After that, we'll actually follow an update on its journey, look at a really critical upgrade to the whole system, and finally, find out what really happens when you delete something.
All right, let's jump right in. The number one challenge for any system like Active Directory, it's all about consistency. You've got all these servers, we call them domain controllers, and they're like the gatekeepers for your entire network. They all need to have the exact same information all the time. So the big question is, how do you make sure a change on one server gets to all the others accurately and without slowing everything down? I mean, can you imagine sending the entire database back and forth every time someone changed their phone number? It would be a nightmare. So Active Directory's brilliant solution is to not treat the directory as one giant block of data. Instead, it slices it up into logical partitions. This means not every server needs a copy of every single thing in the entire forest, which is just the name for the whole 80 instance. So how does Active Directory actually slice up all this data? Well, let's break down the four main partitions that really form the pillars of its entire structure. This table really lays it out. First up, you've got the domain partition. This is the stuff you think of day to day. Users, computers, groups. Pretty straightforward. Then there's the configuration partition. Think of this as the GPS for the entire network. It maps out all the sites and how they talk to each other. It's replicated everywhere. Then you have the schema. This one is fundamental. It's the dictionary, the blueprint that defines what a user object even is and what attributes it can have. And finally, you've got application partitions for custom data. This separation is the absolute key to making replication fast and efficient.
Okay, now that we get the structure, let's actually follow a single change, like you resetting your password, and see how it travels through the whole system.
So every single change, it doesn't matter if it's adding a new user or just tweaking a group membership, it all has to start somewhere, right? Well, in AD, that starting point is called an originating update. This is the first official record of that change, locked into the database on one specific domain controller. Now the journey begins. And this is where it gets really, really smart. First, it only replicates changes at the attribute level. So if you change your password, it only sends the new password, not your entire user account. So efficient. Second, it only sends the final value. If you change a description 5 times in a row, it doesn't replicate all 5 changes, just the last one. Third, it's a store and forward system, passing the update from server to server like a baton in a relay race. And finally, it has this brilliant conflict resolution system, so the most recent change always wins out, even if the server clocks aren't perfectly synced.
But, it wasn't always this slick. Back in the day, there was a huge bottleneck, especially when you were dealing with objects that had a ton of values, like a security group with thousands of members. This led to a super important upgrade.
Yeah, this number, 5,000. In the early days, back in Windows 2000 Active Directory, this was a massive headache. It was the practical limit on how many values you could change in one shot. If you had a group with more than 5,000 members, just adding one more person became a real replication nightmare.
And this slide just lays out the difference perfectly. Look at this. The old way, you add one new person to a big group, and the system had to replicate the entire list of 5,001 members. The new way? It just sends the one new person. It's an absolute night and day difference in network traffic and performance, a total game changer. And the magic behind this is a feature called linked value replication. It came along with Windows Server 2003, and it let Active Directory treat every single member of a group as its own little value. So you can add one, remove one, and only that specific change gets replicated. This is really the reason modern AD can scale to handle these massive enterprise environments. Okay, we've talked about adding things and changing things, but what about getting rid of them? You might think delete just means gone, But in Active Directory, it's a whole different story. It's a carefully managed process designed to stop you from making a catastrophic mistake.
Right, so when you hit delete on a user, AD doesn't just, hit a backspace key on its database. That would be way too risky. What if that delete command got lost in transit? No, instead, the object gets transformed into a special state, making sure the deletion itself can be safely replicated across the whole network.
And it becomes what's called a tombstone. It's a fantastic name, right? It's like the ghost of the original object. Most of its data is stripped away to save space, but the really important stuff, its unique identity, its digital fingerprints, are kept. It's then tucked away in this hidden container where it waits for a while, giving every server plenty of time to hear about the deletion.
So the whole thing is this really deliberate four-step dance. First, it gets marked as deleted. Then, its name gets mangled, so you can't create a new object with the same name and cause a conflict. Then, it's stripped of all its non-essential data. And finally, this new tombstone is moved. See? It's handled just like any other update, ensuring it's done consistently everywhere. But wait, it gets even cooler. The system is so smart that it knows some configuration objects are just too critical to ever be deleted. For these special objects, it has a whole other level of protection that goes way beyond just tombstoning. And this part is just incredible. We're talking about the absolute core components of the directory, the very map of the network. If a domain controller gets an update telling it to delete one of these, it doesn't just say no, it actively fights back. It says, nope, that's wrong, and it reanimates its own correct copy, updating its metadata to make it look like a brand new change and sending that back out, basically shouting to the rest of the network, hey everyone, this is the right version. It's a self-healing system.
So what this all tells us is that Active Directory replication isn't just about copying data. It's a system designed for survival, for self-preservation. Which leaves us with this one massive, fascinating question. If the system can literally heal itself to protect its core structure, what kind of ironclad process is needed to intentionally change its own DNA, the very schema that defines everything? Well, that's a secret for another explainer.